Okay, everyone, so now we're going to talk about the measure of spread for the median that we deal with when we're working with a median. And so I think I'm going to, so down here, I'm actually going to add another couple of rows because before we get to the upper bound and the lower bound, we have to do some interim calculations. So the first thing that we need to do is we need to divide our data set into quartiles, otherwise known as quarters. So in exactly the same way that we found our median by dividing our data set in half, we're now going to take each half of our data set and divide it in half again, right? So again, all we're doing is we're saying, look, we've got 18 rows on this side. We want to find the middle, and then so that there's the same number of rows in each quarter, hence the name quartile. And then we use the values in those rows to make some calculations that give us that upper bound and lower bound. So in this case, I know I have 18 rows on each side. If I divide 18 by 2, I get 9. In this case, I'm going to choose the 9th and the 10th row because it's an even number, right? So in other words, I'm going to end up with, in this case, 8 rows on either side of my value. And the value that I will calculate, in this case, it happens that they're the same, right? So it's very clearly going to be 70,000. I would add them together and divide them by 2. And this is what I'm going to call Q1. It is Q1 because it is below the median, right? In other words, I have dealt with the values that are smaller, that are in the smaller value half below of the median. And so this is going to be Q1. So very clearly from this, my Q1 value, and again, remember it's the figure that we're concerned with. I like to have the highlighting because it reminds me which cells I got it from. The value here is going to be 70,000 times 2 divided by 2, which is 70,000. So in this case, I have my Q1 value is going to be 70,000. Q3 is the same thing on the other side. So again, I want to have, I'm going to take the 9th and the 10th rows. So I'm going to count, in this case, 8 rows. And I will do, from there, it's going to be these 2, right? So again, I'm going to highlight them for convenience, for visual reference. And I'm going to say, okay, what's 112,000 plus 116,500 divided by 2? I will just use the calculator to make this fast. Check my math, never know. So I have 112 plus 6.5 divided by 2, okay, is 11425. So it's 114,250 is going to be Q3. Okay, so again, Q2 is actually the median. Right, it has a special name because it has a special value for us, but Q2 is the median. So Q3 is the boundary, the sort of halfway point, or you can think of it as the 3/4 mark, right? So Q1 is the 1/4 mark, the median is Q2, the halfway point, and the 3/4 mark is Q3. So Q3 must always be more than the median, equal to or more than the median. Obviously, if we have a data set where all of the values are the same, then Q3 is going to be the same as the median and even Q1. So Q3 from our calculation is 114,250. Right? So here are my 2 values. What the heck do I do with these? Well, to do this, we are going to look at, let's see, did I do this on quartile? I always forget where I find this. Quartile. So I like this because this shows a very, I really like this image because it shows a comparison between, it's actually a nice visual representation of the calculations that we need to do. So the first thing that we need to do is we need to calculate something called the Inter-Quartile Range. What is that? It's just the value difference between Q1 and Q3. Okay, so it should always be 0 or more. Again, if you have a data set that's all the same value, then measures of central tendency don't mean much, but you might end up with an IQR of 0. Otherwise, it's always going to be positive. So it's always going to be Q3 minus Q1. Where's my Excel? So I like labeling. I like calculating this separately and labeling it because, again, going back to our discussion of process before the break, this is extremely important to vetting and verifying and what we call sanity checking your process to make sure that your values make sense, right? Excel is a powerful tool, as are many of the ones that we use. Obviously, with the visualization tools, we've begun to see this as well. There is a lot of room to make mistakes. They are not going to tell you if you have made a logical error. It is up to you as the human involved to determine whether or not the calculations you're doing are appropriate, and also whether the values that come out of them make sense, because obviously typos, etc., can introduce some serious problems. And again, it's not that there is a formula that I could stick in with Excel and have it do all this work for me. And the precise reason why I don't do that is A, it helps me keep track of what is actually happening and always kind of reappreciating the meaning, because the meaning is important. You're never going to put the words IQ, you're never going to put the acronym IQR into a story ever, right? But you need to understand what it is. And also because, again, if I'm ever asked to replicate my process, which I'm always prepared to do, having these things laid out in distinct steps is very, very helpful. And it helps reassure me that I am doing things, that I'm taking account for each step. So the IQR is quite simply Q3 minus Q1. So it's that minus that. My IQR is, I'm actually going to go ahead and just format these cells to get rid of that decimal point because I do not need it. Okay, so there's my IQR is 44,250. And so now I'm going to come back to this, and the question is, what is the upper bound? So the upper bound, which is always equal to or higher than Q3, is 1.5 times the RQR. Is you start at Q3 and then you add 1.5 times whatever that value is in the IQR. So in this case, I can do this. I actually think it's nice to have like the multiplier even as a separate one. So that's just 1.5 times the IQR. So it's just going to be 1.5. Again, just because I find it's helpful for keeping track of the steps involved. There's no prize for doing these things in fewer steps, to be perfectly honest. And again, if you get confused about what's happened, this is a very nice way to clearly delineate your steps. So now the upper bound is very simply Q3 plus that multiplier, okay? And the lower bound is going to be Q1 minus it. So I'm going to start with Q1 and I'm going to subtract that multiplier, okay? So what does this tell us? What is the meaning? What is the meaning of this? Again, the thing that we are trying to understand here is what is extreme, okay? What's interesting here is that we see our upper bound, and what our upper bound represents is this is showing the measures of central tendency for both median and mean on the same graph. And basically and we'll get to where we use each one in a moment. What we can see is that the upper bound and the lower bound correspond to a z-score of approximately 2.698, approximately 2.7. Okay, so earlier we talked about how any z-score that is greater than 3 or less than -3, anything that is more than 3 standard deviations from the mean is unusual, right? Definitely unusual. Likewise, what this is introducing is the idea that anything that is above the upper bound or below the lower bound is pretty unusual. So again, what we can tell from this is, if we look at the upper bound, we see that our upper bound is 180,000 roughly. What this tells us is actually that the most extreme values we've seen are in 1980 and 1981. We admitted our refugee resettlement ceiling was almost 232,000 and then 217,000. Those are remarkably high levels, whether we look at it through the mean and the standard deviation or the median and the upper bound. Likewise, the lower bound tells us that, again, 50,000, not that unusual, right? In fact, it's not even close. If we look at it, it is not within it is comfortably within the range of normal. If we admitted no refugees, that would obviously be extreme. But even a value like 10,000 wouldn't be, vastly out of the ordinary. It would still be in there with like 95% of the values that we've had. So again, these are the measures of central tendency and the measures of spread are what let us make claims about how unusual a particular measure is. Again, these are not calculations that you're almost ever going to publish or do in front of an audience, but they are an important way of checking claims, whether made by others or suspected by yourself, of extremity, of how unusual something is. And it's very, very important that we not overstate or understate how severe a situation is when we're talking about when we're talking about measures, right? We need to say, is this really unusual? It might feel unusual, but is it really unusual? So what we've learned from this exercise is that 50,000, not that unusual, actually pretty well within the range of normal. The real outliers in this case, and if we wanted to think about outliers, like it's actually the early 80s. Those are the times when it's been unusually high. We could do similar calculations, of course, for 110,000, which was the number that Obama had set at the beginning of last year, or sorry, at the end of last year. The other thing we could look at is the actual number of refugees that were admitted. What's fascinating about this to me, and this is again just from an eyeballing of the data, you all will have a chance to do your own work on it. We'll do this in class, is how many refugees could have been admitted each year versus how many were. And I think that's actually a really fascinating trend to explore, which is how close to that ceiling have we been coming, and how close have we traditionally come over the years. Now, to the all-important question, which is when do we use the median and when do we use the mean? The short version is that we use the median. We use the mean when we have what we call a normally distributed data set. So that is this wonderful, this lovely bell curve. And the idea is that it conforms to exactly these properties. So if any of you have ever had a test curve, this is exactly what they were trying to do. They were trying to say, look, the average should be whatever percentage or grade they determined. And then because this is a favorite of statisticians, and I actually don't know if it applies to sociologists, but because lots of things in the natural world appear to follow even distributions. Lots of things in the human world don't. And so, for example, things like income distribution. So if we were to just say U.S. income distribution, let's see what we get. Let's see if there's any images. Maybe somebody's actually made the graph. Right, so here we have an example of income distribution. This is from Wikimedia Commons. Let's just see, I'm sure there are plenty from other sources, right? But what this is showing is basically, this is what we call an asymmetric distribution, right? The average, that arithmetic mean, is very, very sensitive to outliers. It's very sensitive to high numbers. That's why we see that the arithmetic mean here is almost 16,000 higher than the median. A couple of big values can really pull that average in one direction or the other. The median, however, in many cases, or in cases where it is where you have an asymmetric distribution, the median is a much more appropriate measure of central tendency because it is not sensitive to those outliers. So a couple people making, or a small number of people making a lot of money at the top are not going to affect the median measure. So the question of when do we use them basically is the data symmetrically or asymmetrically distributed? And the way that we can do this is actually to make a histogram. And we'll talk a little bit about how to make histograms in class, but basically one way that we can tell is how close the mean and the median are, although obviously, as we can see, that's kind of a fraught distinction. Usually, if you are uncertain, you can just calculate both. And because there's still a close relationship between them, the chances of something that is extreme appearing different is unlikely. However, it is very important when you're talking about reporting measures of central tendency, and usually the median is a good place to start because there really aren't that many perfectly normally distributed things in our world. But we'll discuss this more in class. I'm going to leave off for here, and I look forward to seeing you all this week.